The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at Objective 3C. And I've got a lot of screen changes to do, so hopefully things will work out okay. If I am talking about something you can't see, please let me know. All right, so let's see if we've got the pen working. Not yet. Okay. There we go. All right, we're going to take a look at problem number 73 over on the left side of the screen. It says translate each expression into an equation using mathematical symbols. Then solve the equation and answer the question. So it says Maria is 5 years younger than Joe. If Maria is 18 years old, how old is Joe? So the question is, how old is Joe? How about if we call Joe's age, let's call it X. All right. Maria is 5 years younger than Joe. So if Joe's age is X and Maria is 5 years younger than Joe, Maria would be Joe's age minus 5 years. Does that make sense? Any questions about that? But we also know that Maria is 18 years old. So if Maria is X minus 5 and Maria is 18, there is our equation. Any questions about how I came up with that? All right, so let's solve the equation. We're going to add 5 to both sides. And we get X equals 23. So how old is Joe? 23 years old. Any questions about this problem? Okay. Let's take a look at 74. Marlene is twice as old as Sam. If Marlene is 10 years old, how old is Sam? So the question is, how old is Sam? How about if we let Sam's age be, let's see. Again, I'm going to use X. You don't have to unless it says so, but I'm just going to go with that. Marlene is twice as old as Sam. Marlene, well, if Sam is X and Marlene is twice as old as Sam, Marlene is 2X. But it also says that Marlene is 10 years old. So Marlene is 2X, Marlene is 10. There's our equation. Two different ways of describing Marlene's age. 2X equals 10. To solve the equation, divide both sides by 2. X equals 5. Sam's age, how old is Sam? 5 years old. Any questions there? All right, let's take a look at, let's see. How about, let's do 81. The length of a rectangle is 8 inches more than the width. If the length is 42 inches, what is the width? The question, what is the width? Call the width. How about if we call it W this time? Mix it up a little bit. All right. Let's see. The length of a rectangle is 8 inches more than the width. So length, 8 inches more than the width. So it's the width plus 8 inches. But we also know that the length is 42 inches. So W plus 8 equals 42. Subtract 8 from both sides, W equals what? 34. So what is the width? 34 inches. All right, any questions on this? Okay, let's see, now we're going to go to page 34. And now let's take a look at problem number 76. Bob's salary is 7/8 as much as Judy's salary. If Bob's salary is $42,000, what is Judy's salary? Okay, so the question is, what is Judy's salary? And we've got Bob, let's see. Oh, my bad. Call Judy's salary. How about if we call it S for salary? Okay. So Bob's salary is 7/8 as much as Judy's salary. So it'd be 7/8 S. But Bob's salary is also $42,000. So 7/8 S equals 42,000. Notice something about these problems. The question is about Judy, but the equation is about Bob. How can we do that? Because there's a relational statement here comparing Bob and Judy's salary. Okay. All right. So what have we got? We've got 7/8 S equals 42,000. And we've talked about when the coefficient is a fraction, we can multiply both sides by the reciprocal of the coefficient of the variable. So this reduces down to 1 times S, or just S. 42 over 7 would be 6. So this would be 6,000 over 1. 6,000 times 8 would be 48,000. What is Judy's salary? $48,000. And there you have it. Okay, any questions about that one? Let's take a look at 77. A lab technician working for Laboratory Associates Medical Enterprises makes 1/12 as much money as the company's CEO. If a lab technician makes $23,000, how much does the CEO make? Okay, so the question, how much does the CEO make? Call that amount. How about M for money, or for make? Call that amount M. Lab technician, let's see. So a lab tech makes 1/12 as much as the CEO, which is M. But the lab technician also makes $23,000. So 1/12 M equals $23,000. We'll multiply both sides by 12 over 1. We get M equals, let's see, if we take 23,000 times 12, we get 276,000. So how much does the CEO make? $276,000. All right. Any questions about that one? Okay. So now, whoops, that's not what I wanted to do. There we go. Panic set in there for a moment. All right, here we have some questions specifically out of WAMAP. Let's take a look at number 8. Nina is organizing paperback and hardback books for her club's used book sale. The number of paperbacks is 11 less than 3 times the number of hardbacks. Nina had 208 paperbacks. How many hardback books were there? So the question is, how many hardback books were there? How about if we call them, how about if we call them H for hardback books? Okay. Nina is organizing paperback and hardback books for her club's used book sale. The number of paperbacks is 11 less than 3 times the number of hardbacks. So let's see. Paperbacks. So the number of hardbacks is H. The number of paperbacks is 11 less than 3 times the number of hardbacks. Well, the number of hardbacks is H. 3 times the number of hardbacks would be 3H. 11 less than 3 times the number would be 3H minus 11. So again, do you see how I'm getting the number of paperbacks compared to the number of hardbacks? 3H minus 11. It also said she had 208 paperbacks. So paperbacks, 208. So we get the following equation. 3H minus 11 equals 208. Any questions about that? All right. I'm going to add 11 to both sides. 3H equals 219. Divide both sides by 3. H equals 73. How many hardback books were there? 73. Tell you what, let's even go and put that in and see what it says. All righty. Let's take a look at number 9. Micah pays $1,748 in rent every month. This amount is $120 more than twice what his brother Gregory pays for rent. How much does Gregory pay for rent? So the question, how much does Gregory pay for rent? And let's call it, how about R? Okay. And then let's see, it says Micah pays $1,748. But Micah also pays $120 more than twice what his brother pays. So his brother pays R. Twice, that would be 2R. $120 more than twice, that would be 2R plus 120. So Micah pays $1,748, and Micah pays 2R plus 120. So we get 1748 equals 2R plus 120. Subtract 120 from both sides. And we get what? 1628 equals 2R. Divide by 2. R equals 814. How much does Gregory pay for rent? $814. Let's see here. 814. Now, I want to demonstrate something. Hopefully this will work. I talked about the importance of units. Let's submit the question and see what it says. Ah, darn. It marked it wrong. I mean, it marked it correct. And to me, the answer should have been, let's see what happens if we put in a dollar sign in front of it. Let's see what happens. What does it say? Yeah, so I was trying to demonstrate something, but it didn't work. Technically, it should be dollars because there's no units over here. Okay, timeout. Give me a minute here. So now I'm going to switch screens around for a minute. Just hang on. That's not what I wanted. Okay. Almost there. Let's see. I want that. Okay. All right. We're going to look at some coin problems. And notice there's a table that's set up. Okay. Let's see here. It says Reba has $2.40 in nickels and quarters. If she has 6 more nickels than quarters, how many of each coin does she have? A table has been provided to help you get started. All right, so let's take a look at number 39, and we'll set up this table. Let's see, number of and total value in cents. Okay, so Reba has $2.40 in nickels and quarters. If she has 6 more nickels than quarters, how many of each coin does she have? What I want to point out here is there is a comparison statement, and the comparison statement is right there. She has 6 more nickels than quarters. So the number of nickels is being compared to the number of quarters. Whatever's at the end of a comparison statement is the thing or item or person or whatever being compared to. That's what we should identify as our variable, which is why you'll see in the table that quarters is called X. All right. So if we call the number of quarters X and she has 6 more nickels than quarters, she would have X plus 6 nickels. Everybody okay with that? Now, a nickel is worth 5 cents. Okay. So if I have 1 nickel, that would be 1 times 5 cents. If I had 2 nickels, that would be 2 times 5 cents. If I had 7 nickels, that would be 7 times 5 cents. Well, how many nickels do I have? X plus 6. So it's X plus 6 times 5 cents. Now, I could have written it like that, but that isn't cents, that's dollars. It says in cents. Okay, so I've got 5 cents times the number of nickels. That's the total value of the nickels. What's a quarter worth? 25 cents. What's 3 quarters worth? 25 cents times 3. What's X quarters worth? 25 cents times X. All right, so what have I got? The total value of the nickels would be that added to the total value of the cents would be the overall total value, which was $2.40. But we need to take the $2.40 and write it all as cents. So the 5 is cents, the 25 is cents, and the 240 is cents. Any questions how I got the 5, the 25, or the 240? All right, let's solve the equation. We'll distribute. We get 5x plus 30 plus 25x equals 240. Combining like terms, 30x plus 30 equals 240. Subtract 30 from both sides of the equation. 30x equals 210. Divide both sides by 30, x equals 7. So if x equals 7, the quarters is 7, x plus 6 would be 7 plus 6 is 13. So how many of each coin? 13 nickels and 7 quarters. All right. Any questions about that problem?
Where did you get the 13?
Where did I get the 13? Okay. So x is 7, right?
Yes.
So plus 6 would be, so x plus 6 would be 7 plus 6. Because we're putting 7 in the place of x.
Okay, thank you.
Seeing it? You sure?
Yeah.
Okay, all righty. Let's take a look at another problem. Let's go on to number 43. Jim has $3.28 in pennies and dimes. If the number of pennies is 6 more than 4 times the number of dimes, how many of each coin does he have? All right. Again, let's make a table. Let's see, he's got pennies. Oh, wait, yeah, pennies and dimes. And the number of and the total value in cents. So Jim has $3.28 in pennies and dimes. If the number of pennies is 6 more than 4 times the number of dimes, okay, right there is our comparison statement. The number of pennies is 6 more than 4 times the number of dimes. The number of pennies is being compared to the number of dimes. So we're going to call the number of dimes X. The number of pennies is 6 more than 4 times the number of dimes. We've got this many dimes, so 4 times that would be this, and 6 more than that would be that. So the number of dimes is X, 6 more than 4 times X, 4X plus 6. Any question about that? But again, it all goes back to a comparison statement. Figure out what the center of the universe is, what everything's being compared to, assign the variable to that. So in this case, the dimes. Total value in cents. Well, pennies are worth 1 cent. So we get what? 1 times 4x plus 6, which is just 4x plus 6. Dimes are worth 10 cents a piece. So we get 10 cents times the number of dimes. Okay. If we take the value of the pennies, I'm going to put the 1 there just to show that that's the value. The value of the pennies plus the value of the dimes would be the total value, which is $3.28 or 328 cents. So we get 4x plus 6 plus 10x equals 328. Combine like terms. Hang on here, I'll get rid of this thing on the screen. We get 14x plus 6 equals 328. Subtract 6 from both sides of the equation. 14x equals 322. Divide both sides by 14. Let's see here. My handy dandy calculator, 322 divided by 14 is 23. So x is 23. But what about 4x plus 6? That's 4 times 23 plus 6, which is what? 92 plus 6, which is 98. So there are 98 pennies and 23 dimes. All right. Any question about that? Okay. Let's see here. Let's take a look at number 45. Yes, 45. Sam has $1.50 in nickels, dimes, and quarters. If he has twice as many nickels as dimes and 3 less quarters than the number of dimes, how many of each coin does he have? Okay. So now we're dealing with 3 different kinds of coins. We've got nickels, dimes, oops, nickels, dimes, and quarters, okay? And this is what the number of and total value in cents. All right. So there's actually 2 different comparison statements in here. The first one says he has twice as many nickels as dimes. So who's the center of the universe there? The dimes. But then there's another one. 3 less quarters than the number of dimes. Who's the center of the universe there? The dimes. All right. So in both cases, things are being compared to dimes. So the number of dimes is going to be X. So let's go back to our first comparison statement. Twice as many nickels as dimes. If the dimes is X, the nickels would be twice as many, 2X. 3 less quarters than the number of dimes. So that would be the number of dimes minus 3. 3 less quarters. Again, do you see how everything's being compared to the number of dimes? All right, total value in cents. A nickel is worth 5 cents. So 5 cents times the number of nickels. Dimes are worth 10 cents. So 10 cents times the number of dimes. Quarters are worth 25 cents. So 25 times the number of quarters. If we take the total value, let's see here, we've got this total value of nickels plus total value of dimes plus total value of quarters equals total value in cents, which would be 150 cents, taking $1.50 and changing it into cents. 5 times 2x is 10x, plus 10 times x is 10x, plus 25x minus 75, distributing the 25. Combining like terms, 10x plus 10x is 20x, plus 25x is 45x, minus 75 equals 150. We'll isolate the variable term by adding 75 to both sides. 45x equals 225. We'll divide both sides by 45. Let's see. 225 divided by 45 is 5. So there are 5 dimes. 2 times 5 is 10 nickels. 5 minus 3 is 2 quarters. Let's see if this holds true. 2 quarters would be 50 cents. 5 dimes would be 50 cents. And 10 nickels would be 50 cents. That adds up to 150 cents or $1.50. So there's your answers. 10 nickels, 5 dimes, 2 quarters. Any questions about that? Okay. Let's see here. I'm going to go back to some problems in WAMAP. Let's see, this is number 15. It says a local theater sold 500 seats for an upcoming play. Ticket prices are for adults are $59 and ticket prices for children are $26. If the theater made $27,784 for the show, how many adult and children attended? All right, so here's the deal. We need to know how many adults and how many children. Okay, so we'll say number of adults and number of children. There's a total of 500 seats. So the adults plus the children equals 500. Okay. Let me ask you this. Let's go to a different screen for a minute here. Suppose there are 500 seats. Okay. And I told you that there were 20 children. So what would be the number of adults? Anybody?
480.
How did you get that?
I subtracted it, but the price might not be right.
No. Don't overthink it. You subtracted what?
20 from 500.
Okay. Suppose I said there were 100 children. Now, how many adults are there?
400.
How did you get that?
I subtracted 500 by 100.
Okay. How about if I said there were X children? How would you get the number of adults? Don't overthink it. What did you do here?
You would subtract 5 minus x equals 5x.
Not
500x
5. Careful.
is x.
It would just be 500 minus X, wouldn't it?
Yes.
Okay, so let's go back up here. How about if we call the number of children X? How many adults would there be? $500 minus X. The total number of seats was 500. So if the children were X, we would take that away from the total to get the number of adults. How are we doing? Are you seeing
Yes.
this? What?
Yes.
Okay, so now, what do we know about the price of an adult's ticket? It's $59 and the children's tickets are $26. So if we take $59 times the number of adult tickets plus, what is it, $26 times the number of children's tickets, we should get the $27,784. Do you see what I did there?
Yeah.
All right, so let's come up with our simplification here. Let's see, 59. I'm going to put my glasses on so I can see what I'm doing here. 59 times 500 is 29,500 minus 59x plus 26x equals 27,784. I guess this is all dollars. Well, everything here is dollars. We'll put the units on at the end. Combining like terms, 29,500 minus, let's see, if I have 26 minus 59, so that's minus 33x equals 27,784. I'm going to subtract 29,500 from both sides. So let's see, 27,784 minus 29,500 is minus 1,716. Divide both sides by negative 33, and I get 52. So number of children, 52. Number of adults, 500 minus 52, which is what, 448? Well, let's see how that's right. Number of children, 52. Number of adults, 448. All right. Any questions about what I did there? Okay. So in this case, they gave us the total number of seats, and they said that the total was 500. So if we let X be one of them, 500 minus X is the other one. Let's take a look at 16. A store has two types of nuts that they will mix together to make a mixture worth $5.79 a pound. If the store uses 13 pounds of a nut that costs $3.90 per pound, how many pounds of nuts that cost $6.90 per pound should be added to make the mixture? The store should add blank pounds of nuts worth $6.90 per pound. And then we've got the work area. So let's take a look here, and let me copy down this work area. Actually, I wonder if we can actually put, no, they won't let us put things in there, so I have to make my own work area. Okay. So this is the work area, number of pounds, cost per pound, and value. And notice, unlike earlier problems where I said in cents, this is in dollars. Okay, so we've got the $3.90 per pound, the $6.90 per pound, and the $5.79 per pound. All right, so I haven't actually done anything yet. All right, now a store has two types of nuts that they will mix together to make a mixture worth $5.79 per pound. If the store uses 13 pounds of a nut that costs $3.90 per pound. So this is going to be 13 pounds. Okay. How many pounds of nuts that cost $6.90 per pound should be added to make the mixture? That's the thing we don't know. So that's our unknown. Okay. So we're going to add 13 pounds of nuts that are $3.90 a pound and an unknown amount of nuts that are $6.90 a pound. All right. So the cost per pound of this top one is $3.90. So the total cost would be $3.90 times 13, right? Cost per pound times number of pounds. Cost per pound of the second one is $6.90. So that would be $6.90 times X. Well, the cost per pound of the final mix is $5.79. If we have 13 pounds of one plus X pounds of another, and we add them together, how many pounds do we have? Don't overthink it.
$13X.
That would imply multiplication. We're not multiplying them. What are we doing? I've
Maybe
got,
adding them.
so what would it be?
13 plus X.
There you go. Or X plus 13. You see how we're adding them together, not multiplying them?
Yes.
All right. So what's going to go in this final column? It's going to be 579 times X plus 13. So here comes our enormous equation. We have 390 times 13 plus 690 times X equals 579 times X plus 13, because this plus this equals that, or I should say this plus this equals the total value. All right. So let's see here, calculator, we've got 3.90 times 13 is 50.7 plus 6.90x equals 5.79x plus, and then 5.79 times 13 is 75.27. Okay. I'm going to put all the X's on the left. So I'm going to subtract 5.79x from both sides. Let's see. 6.90 minus 5.79 is 1.11x plus 50.7 equals 75.27. We'll subtract 50.7 from both sides. 1.11x equals, let's see, 75.27 minus 50.7, 2457. Divide both sides by 1.11. Oh. It says round to the nearest whole pound. Here's what I came up with. I came up with 22.135, yada, yada, yada. So that would be 22 pounds. Okay. So let's see. We'll put in 22 pounds and see what happens. All right. I mentioned this before, but I want to mention it again. In correcting your last tests, a lot of people missed a lot of points because they didn't read and follow the directions. It had to do with mixed numbers versus decimal numbers and whatever. So for instance, here, if I put in, let's see, let's put in 22.135. Let's see if maybe it might take it. Nope, it says it's wrong. Okay, because they wanted to round to the nearest whole pound. So you've got to follow the directions. Okay. We can hear your water running there, Rebecca, or whatever it is. Okay. Thanks. All right, let's take a look at 17. A banker invested money in two investments. The first investment returned 8% simple interest. The second investment returned 11% simple interest. If the second investment was $260 more money than the first, and the total interest for both investments was $138.80, find the amount invested in each investment. Okay, let's see here. Let's see, investments. We've got the first one and the second one, okay? And the interest. So this would be what the interest rate for the first one was 8%, and for the second one it was 11%. Okay. And let's see here. If the second investment had $260 more money than the first, so we'll call this interest, that's the money. The second one had $260 more than the first. So the first is X, the second is X plus 260. Okay. The total interest for both investments was $138.20. Oh. So this is not the interest. Let's see, the second investment returned, the second investment, this is the investment. So hang on, this is wrong. What do I need? I need the principal. So the principal was X and X plus $260. Why did I change that? All right, here it says the second investment had $260 more money. I was assuming that meant the return on it, but it was the investment, okay? The total interest was $138.80. So this would go there. Now, let me get my eraser out and clean this up a little bit. If you invest X amount of dollars at 8%, what would the interest be? It would be 8% of X. Notice I converted the 8% into a decimal number. If I invested X plus $260 at 11%, that would be 0.11 times X plus 260. So the interest from the first investment plus the interest from the second investment would equal the total interest. Okay, and everything's in dollars here. So we've got 0.08x plus 0.11x plus 260 times 11. Oh, not 260 times 11. 260 times 0.11 equals 138.80. Glasses on so I can see the decimal points. 0.08x plus 0.11x would be what? 0.19x plus 28.6 equals 138.80. We'll subtract 28.6. And let's see, 138.80 minus 28.6 is 11.02. We'll divide that by 0.19 and we get 580. So find the amounts invested in each amount. This would be 580. And this would be what? 580 plus 260, which is 840. So the 8% invested would be 580. And the second one would be 840. All right, we're out of time. Anyway, so for tonight, you've got this section. I'll be back at 1:15 with an office hour. Should you have any questions? Otherwise, have a great rest of the day and I'll see you tomorrow.